In today's video, I'm going to discuss power banks and battery sizes and how to power your telescope equipment. Now, I am really happy with this. This is my homemade power bank. It's got two 20 amp hour lithium iron phosphate batteries in there, and I have an energy meter. And if you've been watching my channel, you'll probably realize that over time I've got more and more batteries, and that's because I keep upgrading my equipment. So here's my current setup. I've got a ProCool camera, guide scope, focuser. I have a filter wheel that isn't installed because this is a one-shot color, but I have a mono camera that I can use for a filter wheel. And this afternoon I'm going to be installing a dew heater that I've ordered, and that's going to help me image a little bit longer in the winter as we are now. It's really humid, and so over time it's just gotten bigger and bigger and bigger and had higher and higher power requirements. So I want to go through and show you how to size your battery bank appropriately so you don't get in any kind of trouble. And then specifically I'll be going over how you can connect it with the ASI Air. Now there are a couple approaches with the ASI Air. So they have these power outlets right here. And so what I've done on this particular configuration is that I have a powered USB hub, and I bought one that was 12 volt. And the reason I did that is because I wanted to make sure that I had full power to these USB outlets, and I'm not trying to rely on powering these. And so I got here's my data port for the images, and then the focuser is now from a powered output. I don't want it from here. And I have some other power outlets here. So this afternoon I will be putting a dew heater. I bought a 12 volt version to one of this, and then I can keep my cable management nice and tidy. And so what I've done is I've wrapped the excess around here and then on down to the back here, and I've got twist ties and whatnot. So I don't want any more cords hanging down than I have right now. Now what you will not see here is the mount. The mount here needs to be connected directly to its own power supply. And in my case, Skywatcher says a minimum of 4 amps. And that is really important. The power output, the max here on the ASI Air is 3 amps. You do not want to power your mount from one of these ports. So that's why that is like that. Now I could power my the power cord on the cooled camera. I could do that from the ASI port, but I just go ahead and plug it into its own power supply here. The cables never snag. All it does is swing back and forth, and so I just run the mount here, the ASI here, and then the cooled camera. That's how I do it. Now if you want to just run two, one to the ASI Air and one to the mount, that's fine, but I designed mine to have 6 outlets, which means I could do this same configuration twice with this one battery bank here. And so I want to show you how to size it based on these various options. Now you can see here that I've got this energy meter, which is a separate project, and this shows me the current that it's drawing instantaneously, the total amp hours over time, and the watts. And I'll show you why I did that and why it's important. The best way to do this is to add everything up and get really organized, and so that you know exactly what you're doing. And so I've built a spreadsheet here where I can put all of my variables in, and then I can say how much it is over time. So over here on the summary page, I can put in the total imaging hours, and right now in the wintertime I can do about 7. So right here I put in some notes. The amps needed for the mount, you should do at least 5, but you should look at your own spec sheet for whatever mount you're using. Some really high capacity mounts might have even higher. But I'm doing from my Skywatcher EQ-M35 Pro, the spec sheet says 4, and so I just up it to 5. The cooled camera, the one I'm using, the ASI, the 294 of MM Pro and MC Pro, and they need a minimum of 3 amps. So the minimum amps is 5. Now, why is that important? Well, the battery size that you choose is going to have a current carrying capacity. And I started out with a small 6 amp hour battery, and I didn't have hardly any equipment, and it had a maximum current of 5, and that's why I chose it, because it was over the mount. So anyway, this column is the continuous watts and the continuous amps, and so this is where the difficulty comes in, because if we go to any kind of a spec sheet, they're just going to tell you this column, the max. They're not going to tell you what it pulls to run it all the time, and that's very frustrating. So this is why I built the amp hour meter, or the energy meter, because I wanted to know what the continuous output is. Now the ASI Air will show you, but like I said before, you should not plug your mount in. So how are you going to know how much your mount is actually using? Well, in my test, it only runs about 3 watts, but not when slewing. So when slewing, it uses about 1.1 amps, but it slews for maybe, 45 seconds to get to its next target. And so it's fairly insignificant over time. What's important is how much it uses continuously. So if we put in, I calculate by amps. Watts is a calculation of the amps, because amps are what's important to me. So I say 13 volts would be an average for a 12 volt battery, so this brings you at about 3.25. And then over time, we take 2.25, which is what I have tested it to be, times 7, and that's going to be 1.7 amp hours. So that's what you would need over time. And we do that for each one of them. Now the cooled camera, I have not specifically isolated the cooled camera, but it's around an amp, and so that's about 7 amp hours for the night, and that also is highly dependent on your ambient temperature. So if in doubt, put in the largest amount that you know, and therefore you will be covered in all temperatures. And so in the wintertime, it's not going to pull an amp. It just won't. But in the summertime, it probably will, and maybe up to a maximum of 3. That is yet to be determined, to see if I can actually measure that. But we could put in 3 here, and you can see how everything will change. So I like to put in a little bit of safety factor, but for right now, it's about 1. Now the dew heater, I looked from the spec sheet. I have not tested it because it is out for delivery. And the spec sheet for the DH30, which is the one that I purchased, is 0.31 amps. So I'm just going to put that in for now. And we do this all the time. Now the focuser and the filter wheel just hardly use anything at all. I mean, it's just next to nothing. So instead of putting 0, I put in 0.01. But we can add those all up, and you can see under my current configuration, it's about 11 amp hours. So if we take this data and we go back over here, the next question you have to answer is, how much are you willing to discharge your battery? And so I do not like 100% discharge on any battery. I think it is a bad practice. It wears out your battery quickly, and it gives you very little safety factor. So if we put in an 80% maximum discharge, that means that the minimum battery capacity, if you take 11.06 divided by 0.8, that means you have to have a slightly larger capacity. Now let's say that you are only willing to discharge to 50%. You see, this greatly increases the capacity size that you need. And so you might do something conservative, say 70%, because over time batteries degrade, and they typically say that like over a 5-year period, or about 3,000 cycles or something like that, you should be able to get about 80% of its capacity. So if we stay a little bit more conservative and say 70%, this puts us to nearly a 16 amp hour battery. So I had already done this calculation, and I want to run 2 telescopes, so that would be about 30 amp hours, which is more than to 20, so I went ahead and bought 2, and this will allow me to upgrade and make it future-proof, at least for 2 telescopes in pretty warm conditions, as far as, like trying to cool it, or cool conditions trying to warm the dew heater. So there are some give and take in these calculations, but this is basically how it works. All right, now how are you going to do this yourself? If you built one of these, this would be great, because this is going to tell you what's going on. So I just powered it on, and we can see the watts that it's pulling right now. We are not tracking, but we have the Pro Cool camera on, and it's quite cold out here, so it's probably not going to be cooling very much. But if you have the ASI Air, here is one way that you can do it. You can use a power supply that, like a commercial one that plugs into the wall, and then to power this, and then start turning on your devices one at a time, and then go inside the app and see the power rating, unless you have something cool like what I've got here. Alright, so if you go into the ASI Air and you press this little button right here, they tell us what it's pulling. And so this is going to be 0.4 amps and 4.5 watts. So this is showing the focuser and the guide scope, the guide camera, etc. And I don't have any of those on, but let's go back and compare this to what my energy meter is saying. And so that's what we're pulling there. But this also includes the mount. Now the mount is going to draw power, but it won't be very much, because when the circuit is on, then it's going to draw power. So this is slightly higher than the ASI Air. So if you don't have an energy meter like this, then you can use the ASI Air to get a good idea of what your continuous power is. You go out, you start your imaging session, you turn everything on that you're going to use, and then check the power and the current, and then that'll give you a good starting point for your calculation. Now, like I said, you can't measure the mount this way, so you're going to have to make some estimations like I showed you in the spreadsheet. So I hope you found that helpful, and I'll see you next time.